Hello and welcome to the fourth part of the video series, First Steps in the Facade Arch. I would like to further consider how I can create the metal connections on the side, in the central area, and also in the floor area. I am aware that I am also dealing a bit with sheets here. Therefore, I will quickly create an assembly here where my sheets will be collected. I will do this again with a structural assembly, as this assembly restores order for me. At the same time, I would like to collect my sheets for the entrance and facade. I will reference these sheets again shortly so that I can use them everywhere. For this, I again pay attention to the world coordinate system and retrieve the text so that I can use it again. I reference this structural assembly and so I can use this structural assembly anywhere. Now I switch back to my detail. That means this is my detail section here that I would like to edit again. And I would like to pull my detail, meaning my sheets of the entrance facade, back in here. For that, I will look for my corresponding article again. I just noticed that I wrote this incorrectly. It should of course be called entrance facade. This is an important step because the entrance facade is a critical element in architectural design, serving as the first impression of the building. I will rename it later and pull this facade back out, ensuring that all references to it are consistent throughout the project. So, now I have renamed this as well, and the text is correctly adjusted with me. This adjustment is crucial for maintaining clarity and coherence in the documentation. I also need to change this in the document, which involves updating all instances where this term appears. I like to do this because I named this detail 1, but when creating it, I didn't pay attention to what my detail is called. This oversight can lead to confusion, especially when collaborating with others who rely on precise terminology. I want to change this detail here and modify the detail designation to ensure accuracy and consistency. As you can see, in this case, it wasn't done well, so I will remove this text and just call it 1. It often happens that I prefer to have only one detail on a plan, because I frequently copy these details and add them as a three-dimensional representation. This ensures that it is often shaded, and I can simply enter this into 3D, which I can change at any time later. The ability to modify 3D representations is invaluable, as it allows for flexibility and adaptability in design. So, I have now set detail 1 to 10, and I will make it a bit smaller or larger in this case, so that it is a bit more visible. Adjusting the size of the detail ensures that it stands out and is easily identifiable. Here, every change I make will always be reflected everywhere, which is a significant advantage in maintaining uniformity across all documents and plans. I also want to remove the header from the upper area so that I have more space. Removing the header provides additional room for other important elements, enhancing the overall layout and readability of the document. So, my first detail is now finished. In this case, I will create a new detail. Save As for a new article base. This is my second detail for another detail view. This will be my detail SIR2 and is a vertical section of the ceiling. In this case, only a copy of it was actually created. That means now I basically have two drawings of it. I can now check this again in Helios, where I have my second drawing of it. Therefore, in this case, this detail is also incorrect, which I will remove again right away. And this cut is also wrong in this case. I don't need it here anymore. That means I mark a vertical section, which I specify here in this area. Depth limitation can again be at 1 meter, and the cut should again be limited. That means I just place my cut in the area that is relevant to me. The overall section, to provide an overview, should of course extend over the entire height. And thus, I also generated this section immediately. From this, I create my second detail. That is to encompass this area. I also specify the detail designation correctly here, and in this case, I immediately have my second detail as well. In this case, you can also see the console here. I can, of course, continue working normally at any time. This means I would like to add more things here. I will simply start with a suspended ceiling, which should be at a certain height. This means I go into my construction area, generally look for a sketch, and draw this suspended thickness. I choose from my semi-finished product the one where I can assign various values, where I can also define it with different values, and where I can define it with lengths and values in length. In this case, it should be 1 meter. This is actually rather unimportant here. I mentioned earlier that it extends in both directions from the cut, and in this case, I have actually created my suspended ceiling thickness quite simply. I would, of course, like to have this suspended ceiling in the construction kit at some point. I can do this now or do it later. It is always important in such cases to work with height coordinates. This means that I want to define height coordinates here so that I can see where my suspended ceiling is, where my values are, so that there is a bit of a reference here, so that the architect actually has a reference for where the parts are. You can also see here that the suspended ceiling naturally occurs everywhere. This means that you naturally save yourself the work of dealing with various cuts. No matter where you do it, everything is always up to date. The parts can also be relatively easily modified, meaning I can go here, for example, and say I want to adjust this to a certain dimension. This means we have 163 here, and I want to move this up by 13 meters, which means I have a build-up of 150 here. Alternatively, I can also go to a round number, which means I would need to have 1300 as the height dimension. You can see that the cuts are always crossed out. This simply means that the cuts and hatching may not be current. I have a macro on the keyboard, which means in this case I can start this command, for example, with the X key, and it will recalculate for me. What I always do in such cases when I am working in detail is to only display the active view, as this is usually much faster. I can continue to work on the edits or also draw the sheets further. That means I want to place a sheet up here and drag it down. That means I create a sketch here, place it on the cut, and draw the flow of the aluminum sheet. This sheet should go from here to here downwards by a certain value. Now I can, of course, dimension this with the intelligent dimensioning as well. This means I want to have 5 mm here. From the top edge of the tile, I want to have 20 mm down. And I would like to start from the edge or from the back edge. It doesn't matter what I base it on. I can, of course, define my values here for how this aluminum sheet should be installed. I just need to know one thing. Either I draw the outer edge at the edge, which means that if I need to draw the outer edge here, I must of course add the material thickness of 5 mm for clearance. I want to select my sheet with the right mouse button, which means a 3 mm aluminum sheet, and the thickening direction is on the first side. The sheet thickness can again be 1 poissime, and I can specify the length here normally, as it is only important for the cut in the first step. Furthermore, I can go ahead and also represent a silicone joint and model the parts in order. It is important to note that I can, of course, change the aluminum sheets at any time, even if they might not fit at some point, which they currently do not. This means I could go here and also edit the sketch. I could draw normally here. For example, I could add a tab on the edges or create a shadow, whatever is needed repeatedly. This means I want to input a leg in this case, just to show that I can easily change things at any time. Of course, everything will look quite different in the end, but often the first step is just to have certain discussion topics, like how the parts look, what is important here, and what is needed. I will also pull this view back into the aluminum sheets at the entrance facade to ensure it is correct. For example, I can also include the filler material. Some things are only needed in the cut, so I would currently leave this filler material in. So, I will now assume in the first step, in the initial phase, that the suspended ceiling has been drawn by the professional architect and designer, and I would like to make a secure sheet metal connection here and attach a sheet metal angle with high quality screws. This means I want to go to this outer edge with 3 mm. The length of the leg should be approximately 30 mm, and this should also be because I did not assign that earlier, or it should be a decorative shadow joint. This means I want to have a shadow joint here with precision and accuracy, with 20 mm plus, possibly the material thickness added. That means I can also calculate normally here and enter the values. I am only stating the material thickness here, the length, and with that I have my second sheet. Then I would like to add an additional sheet metal piece here, and this is of course considered a suggestion again, because a fastening must actually be created here in further regard, which I need to clarify with the architect at this point. I mistakenly set this condition, meaning I actually want to have 20 mm here. So the 20 And then of course this leg must also be shorter. Initially also 20. What is important for me now is that this should be flush. And now I show here again that a sheet should be flush, which in this case was also incorrect, but these are exactly the kinds of things that need to be changed repeatedly. So now I have simply created a few parts to show it. I can go ahead and either edit this sketch, saying, okay, I want to edit this sketch, or I can work normally with cutting, meaning I could also go ahead and say, okay, I want to have 5 meters of space, and the upper area should be removed, and thus I have adjusted it, for example. To clarify further, the fastening needs to be discussed with the architect to ensure it meets the necessary requirements. The mistake in setting the condition was due to a misunderstanding, and the importance of the sheet being flush cannot be overstated. When editing the sketch, I have the option to make precise adjustments, and working with cutting allows for flexibility in modifying the design. Adjusting the upper area is crucial for achieving the desired outcome. So there are of course many ways to get there, and the suspended ceiling is supposed to come here in this case, for example. So I can actually move and rotate the parts back and forth as I wish. If I now look at the details, again, I have of course everything I have just shown. You can see it here, here, and here. And if I switch to the complete 3D model, you can also see that this sheet metal is present from the back in the 3D view. As long as the sheet metal is not finished in terms of shape, such collisions, like in this case with the post, are totally irrelevant. First, you always have to define the cut and model everything that is necessary for that.